In the early stage of prehistoric studies, dating of any event or site was often tentatively. A particular event or specimen is dated in relation to other event or some reference point. These type of dating techniques are known as relative dating, by which one can know whether a particular culture is younger or older than another one. That is, through relative dating, it is known that culture A is older than culture B, but how old A and B are, or how much later B is than A in terms of number of years is unknown. Say for example, there is a stratified site, then here we find a number of strata. Here we find culture B and we find culture A here. Then we can easily understand A is older than B or B is newer than A. But how many years it is older or how many years it is newer is known to us. These dating methods have never been able to provide a date in terms of year, nor it can calculate the total time span involved in each cultural period. However, with the help of such dating method, a series of things can be arranged in a sequential time frame. The relative chronology, in the words of Wheeler, in 1956 is, quote, the arrangement of the products of non-historic societies into a time relationship which may not have any dates but which has a sequence, unquote. Till the early part of the 19th century, quite a good number of relative dating methods have been in use in archaeological studies. These relative dating methods are basically depending upon stratigraphic position of the site or kind of remains associated with the site. Some of the relative dating methods are stratigraphy, typology, fluorine tests, uranium and nitrogen analysis, paleontology, palynology, cross dating and sequence dating. However, our discussion will be restricted only to two types of methods, that is stratigraphy and fluorine tests. Let us see the meaning of stratigraphy. Use of stratigraphy is the most important method for establishing relative dating. The simple meaning of stratigraphy is the study of strata or layers. It is the analysis of a series of layers that exist in a site in a horizontal dimension through which the vertical time dimension can be read out. Now let us see its principle. The method depends on the geological law of superposition. According to this law, in an undisturbed stratification of deposited material, the lower strata are successively older. That is, the top level is more recent formation and the lowermost level is the oldest. Therefore, whenever a stratigraphic sequence is observed during the excavation of a site, relative ages of the cultural level can be worked out. The stratigraphic association of artifact types within and between archaeological sites are regarded as one of the very important methods of relative dating. Now come to the formation of strata. Stratigraphic layer in an archaeological site represents culture in the form of deposits of artifacts as well as ecophags. Such layers are formed either naturally or due to human occupation in a particular area. The former is called geological stratigraphy and the latter is archaeological stratigraphy. Both are important to derive relative date of a particular site. The formation of strata, either geologically or archaeologically, is a long process. Prehistoric people usually occupy open-air site and rock shelters. The first comer will be making their home on the natural floor of the rock shelter. But as time passes and one generation follows another, the floor level will be becoming covered with material such as mud, dirt, and debris thrown by the occupants. The descendants or successors of the original settlers or newcomers will be living on the top of the deposit and adding in their turn a new layer of the accumulating debris. And sometimes it becomes so high that rock shelter becomes no longer suitable for habitation and finally abandoned. When climate changes and the situation of the earth is being altered and so on, it frequently happens that the new layers may have a different consistency or be made of different materials or be made of different color from the earlier one. It helps the excavator to mark the layers distinctly. If an excavator cuts section of the rock shelter showing all layers from top to bottom, he can apply the law of superposition. Accordingly, the bottom layer will be the oldest and the middle layer intermediate and the top layer the most recent. Prehistoric man frequently drop his artifacts and these become incorporated in the various strata. Artifacts collected from the strata also give clue to the industry of the stratum. Thus, complete excavation of a site enabled the prehistorian to determine the sequences of the strata and the sequence of the industries. When a number of excavations is carried out in a site, it enables one to characterize the assemblage of industries of successive dates. He can also determine the sequence of strata. The sequences of culture can be determined by comparing the results of number of separate excavations. Natural disasters such as earthquakes or volcanic action naturally does not disturb the Earth's strata. Artifacts assimilated in the strata do not get displaced, but to such natural movement of Earth, prehistorians are not concerned with such disasters, but are concerned with the problem arising through burrowing animals such as rabbits. Rabbits usually drive their burrows through the wall of the rock shelter. As such artifacts present in the rock walls get displaced and the industries consequently get mixed. Now come to the application of this technique. Most of the archaeological sites have been dated by using stratigraphical method. One such example is the identification of existence and position of Mesolithic phase. Until 1865, the Mesolithic was not identified as a distinct cultural stage in man's history. The Mesolithic gained recognition as a separate cultural identity only after the discovery of the type site at Mas-d'Azil, a cave in France near the famous Magdalenian site. Excavation at Mas-d'Azil shows that Mesolithic tools occur over a sterile layer containing the Magdalenian or Upper Paleolithic implements. Above the Mesolithic tools, a separate layer was found which contained Neolithic tools. So, the existence of a transitional phase in between earlier Upper Paleolithic and Neolithic phase was realized. Stratigraphic method can also be applied in open-air sites. Due to successive occupation of these areas, layers may be formed one after another and there may form some mound. Excavating such mound reveals stratigraphic sequence, and according to geological law of superposition, chronological sequences can be worked out. In prehistoric sites like Nevasa in Maharashtra, Lothal in Gujarat, excavation of mounds expose cultural levels ranging from 3000 BC to historical period. Excavation of river terraces also reveal succession of culture in stratified contexts. In India, terraces of Narmada, Godavari, Malaprabha, Ghattaprabha are found very potent in having cultural deposits of Indian Stone Age. Now come to the demerits of this dating technique. The kind of chronology one can derive through stratigraphy infer a culture in terms of older or younger than other one. But it cannot ascertain the exact date for any of these cultures. Secondly, it is not possible to obtain stratigraphic sequence everywhere. Therefore, its applicability is limited. Stratigraphic sequence in many places can be exposed only by applying excavation technique, which is very costly and time consuming. Now let's come to its merits. Number one, it gives the proper culture sequence, and number two, it helps to understand the industries of different cultures. Fluorine test, another method of relative dating, was first devised by a Frenchman called A. Carnot in 1893, but later on it was perfected by Dr. Kenneth P. Oakley. Fluorine is a non-metallic element. It is pale yellow in color and is a highly reactive gas. Fluorine test is not isotopic and it does not measure elapsed time. It depends on the fact that bone and tooth, that is calcium phosphate, absorbs fluorine dissolved in percolating water and forms fluoroapatite compounds. At any given site, bone, that is human and animals, of a particular age will yield the same percentage of fluoroapatite. Prehistoric sites often consist of many bone remains. Fluorine analysis discloses the percentage of fluoroapatite in bone specimen found in archaeological sites. The basic principle of the method is that the longer a bone is placed in soil, the more fluorine will be caught in, and hence can suggest a relative date. All bones, whether of animal or of human, lying in the same level exhibit similar fluorine percentage in them. Therefore, if the quantity of fluorine remains same in both kinds of bone, it is sure that they belong to the same age. The bones acquired from a lower level show more fluorine in them, whereas the bone remains coming from the upper level contains less fluorine. Relative ages of different bones at the same site thus can be established by measuring their fluorine contents. Fluorine test is generally applied to the mixed deposit of human and animal bones. The method cannot calculate an absolute chronological age because the amount of fluorine differs from soil to soil. The amount of fluorine that gets into a bone depends upon how much is present in the groundwater, and this varies a great deal from place to place, which gives a differential rate of absorption. But the methods like fluorine, uranium and nitrogen analysis have been found quite suitable for the relative dating of bone materials within a particular site. For example, it played a major role in exposing the famous Piltdown forgery by demonstrating that the jaw of alleged early specimen of man was of modern age. Method of dating that helps to derive age of a site or object found in a site with reference to other site or sites or object is termed as relative dating. There are a number of relative dating methods. Stratigraphy is one such important relative dating that studies strata or layers. The method depends upon basic geological law of superposition, which states that among the layers, the lower layers are older than the upper ones. Thus, in a prehistoric site, when there are stratification, it gives relative age of different cultural deposits accumulated in different strata. Fluorine test is another relative dating method, which means fluorapatite date deposits in bone found in prehistoric sites. As the content of fluorapatite varies from soil to soil, this method is applicable in case of bone found in the same site only.